Cheers and welcome back to Lem's Cryptoverse. So today, I want to talk to you about something special. I looked all over the internet and everywhere else, like Twitter and whatever. I could not find much or any information on how to analyze a project's decentralization. Yes, there's lots of information in terms of how many nodes are there, and they talk about decentralization, but like in one paragraph or two. The only in-depth articles I could find were like these PhD statistical papers, and they only cover one aspect, and that's like the Nakamoto Coeficient, which we'll explain later. So today, I'm going to do something different and cover all aspects of decentralization and how it affects crypto projects and look at specific crypto projects as examples. So let's get started. Here we go, analyzing a project's decentralization. And remember, this is NFA, not financial advice. So crypto projects must be analyzed, in my opinion, like everything else, holistically. So when you're looking at stocks, for example, you're looking at macroeconomics, fundamentals, the technicals, meaning a stock chart. Same thing with decentralization. You can't just look at a number. So before we get started, let's talk about the Blockchain Trillemma. I like to call this the Holy Trinity. And as most of you know, it was coined by Vitalik Buterin. He says there's three main issues, and I've got them here in the triangle: decentralization, security, and scalability. And when developers are building a blockchain, they encounter these issues, and the problem is you can't have all three at the same time. There's going to have to be a trade-off. So my second point there, it says it's a widely held belief that this trinity cannot exist. And so which ones are most important? This is opinion. I think that whilst decentralization is important, it's not the most important issue or aspect when a blockchain is getting started. Because think about it, blockchain's getting started, you want to make sure it's working properly. So it's not fully formed. For example, governance takes time to become on-chain, right? It starts off-chain and then it moves on-chain. The same thing with decentralization. You start out with a few nodes, and you want to make sure the blockchain's working properly, so you want to make sure there's some control. And then over time, you expand on that. So I would rank decentralization as being important, but not being vital as the other one. Security, I think, is very important. And scalability. Scalability, for example, or speed, like you for the most part, you don't have like a slow blockchain and then eventually gets faster and faster, meaning it goes from being like a snail, like Bitcoin, to being as fast as Solana, or like 1 million TPS, transactions per second. It doesn't work like that. You usually know how fast a particular blockchain project is at the get-go from the white paper. So I would worry more about scalability in the beginning rather than like decentralization. Decentralization, like I said, can change over time. So what's the conventional thinking on decentralization? Well, for proof-of-stake networks, everyone asks, does it have a lot of validators or nodes? That's all everyone looks for. And for proof of work, meaning Bitcoin mostly, but could be other things. It used to be Ethereum, it's Monero, that's proof of work. People are looking for miners. Does it have lots of miners? But maybe, just maybe, decentralization is a sliding scale, and it should be applied, like I said earlier, holistically to all parts of the blockchain. So what is the formal definition of decentralization? Before I give you what I think of it and what you should be looking for, maybe I should tell you how it's defined. So you could stop this and read this on your own, but so I'll just talk to you about it quickly. So in the blockchain, decentralization talks about or alludes to the transfer of supervision or decision making being from one centralized association, and that usually means a corporation, to a dispersed network. Second point, decentralized networks, they also try to decrease the amount of trust that's needed. So the amount of trust that we need on that organization. That's very important. That's why they call them trustless and permissionless. So what are the benefits of decentralization? Decentralization, well, they facilitated a trustless setting. All these $15 words, by the way. They improve data recovery. They reduce the shortcomings, and they optimize asset dispersion. So think about that. If you pull the plug on one server, the blockchain's still going to work. That's what it's saying. So here I'm going to talk about the differences and basically pros and cons, but also differences between centralized and decentralized. And just because something's decentralized does not mean it's better. Just keep that in mind. So I'm just going to talk about a few of these. So the centralized, and I'm looking at row number 1, a centralized blockchain or company has information flow going to and from the center. So if you're using Google or Facebook and Meta, it's going from me to Meta, from Meta to me. If you're looking at the internet or blockchain, there's multiple routes, right? It's like a spider web. Decision making, that's the second row here, is usually from the top down, hierarchical. And decentralized chains, blockchains, it's democratic. You hear that, Elizabeth Warren? Control, as you know, if it's centralized, obviously it's a central entity that's controlling it. Let's see some pros for centralized. Simpler decision making, less expensive hardware, more control. Control in a good way. If you trust in them, if you trust in that entity, then you want more control by them. Now, decentralized, the pros is that are that it's immutable, it cannot be changed, it's transparent, everyone can see what's going on. That's a pro for decentralized blockchain. Cons or disadvantages. Well, if you centralize, it's a single point of failure. We saw that with FTX, and there's some examples below. Binance, Coinbase. So if you're a brokerage, you tend to be centralized, and that's a whole issue we all know about. And if it's decentralized, we have some issues there too. Expensive hardware. Sometimes criminals can use a blockchain, but more and more, in the long run, it's not really anonymous. It's pseudonymous, because eventually you can be found if you're doing something bad behavior, basically. A company like Chain Analysis can track you down. So why should we care about this? Well, I mentioned in the previous slide. If you're using something, a blockchain that's decentralized, it's trustless. We don't have to worry whether or not that entity is to be trusted, I should say. We don't have to worry about FTX, for example. And it's immutable. You don't have to worry about Google or YouTube removing data because they favor you. Maybe there's some bad data about you and they're removing it. And that's because maybe you have a relationship with Google. Or maybe they worry about how much power you have against them. So it may not be immutable for the little guy. Maybe non-immutable for the big guy, but immutable for the little guy. So you have to be careful about that. There might be there's no single point of failure, and we discussed that already. Another thing we should care about if you're an investor is if your blockchain is decentralized, then you don't have to worry about it being regulated as a security. If you're a security, that could be life or death if you're a small blockchain, because number one, it's expensive to do all the paperwork and legal team and all that. Number two, the governmental authorities may not allow you to trade in that particular token or coin if it's considered a security, and that token and coin could go bye-bye. I mean, there's a whole bunch of reasons why you should care. And basically, it's more democratic. So what's a Nakamoto Coefficient? So I mentioned earlier in the presentation that the way people look at a blockchain being decentralized is by how many nodes or validators that it has. But there's a better way, and that's using the Nakamoto Coefficient. And so you can stop this presentation and take a snapshot of it and read it on your own. So I'm just going to go over a few things. Number one, the Nakamoto Coefficient measures decentralization, being that it represents the minimum number of nodes required to disrupt the blockchain's network. So you want a higher number. So the higher the Nakamoto Coefficient, that means it's better. It means the more nodes that need to be controlled to compromise that network. So the Nakamoto Coefficient was first described in 2017 by the former Coinbase CTO Balaji Srinivasan. He's also the guy that recently said that Bitcoin's going to $1 million in 90 days. I don't know. This guy does such smart things and he says stupid things. I don't know. So he tried to make a quantitative way of determining whether or not a network was decentralized. And he looked at two things. He combined the Gini coefficient and the Lorenz curve. You could look on your own to see what they are, but basically he tried to look at, and this is the last point here, he tried to look at different subsystems. That's the key point. Looking at different subsystems. He didn't just look at how many nodes it had. He also looked at which subsystems were controlled, meaning were there whales that controlled it? Were the nodes overly reliant on Amazon Web Services or Microsoft Azure, for example? So simply put, a Nakamoto score describes the minimum amount of effort or work or money that it takes to disrupt any given blockchain. Forms of centralization. Now, this is the meat of the presentation explained to you today. So you could look at these on your own. So I'm going to go over them quickly. And what I try to give to you in terms of value add is number one, showing you that there's over a dozen ways that a blockchain could be centralized. And the second value added I'm trying to give you is I'm actually giving you concrete examples from each specific blockchains where you can see that blockchain could be controlled. So let's get started because there's a lot to go on. There's a lot to talk about. Number one, if the blockchain can freeze accounts, in this case, this blockchain could do two things. They're also issuing relay nodes, so specific nodes, so only a few nodes that can control the blockchain. So if it's doing one of those two things, it's basically centralized. And in this case, it's Algorand. So I mentioned Algorand's founder because Sylvia McCallie was quoted as saying that he could freeze accounts, that Algorand could freeze accounts. So talk about control. So let's go to the next one. Number two, control by a related entity or for-profit foundation. And an example of this is Ava Labs, that's behind Avalanche. Number three, if the developers are affiliated with specific VC firms or other organizations, in a way that's control. And you saw that with the Solana dApps and FTX. Point number four, manipulation. You can have a VC firm or hedge fund controlling that blockchain. And again, we saw that here with Alameda Research. There also could be nodes that are controlled by a coordinator, which could shut down that network. And this happened, actually, this really happened with IOTA. I'm not sure how many of you know IOTA. That's the Internet of Things blockchain protocol. It's very interesting. But they were able to shut down their blockchain. So I think we're at point number 6. Unequal distribution of nodes. So you want to make sure the nodes are distributed equally or somewhat equally, geographically or whatever. Next point, reliance on one cloud provider, and I mentioned that earlier. Next point, the foundation or the individual, they may control the administrative keys, meaning they can control the software. If they control the software, it's game over for that blockchain. And I've already found 3 big, well-known, or at least 2 well-known blockchains. That's Thorchain and Polygon. And then we have the Serum DApp on Solana that was controlled by FTX, by Sam Bankman-Fried. So this is a major issue. Next point, the blockchain publishes a unique node list, UNL, and this is what Ripple Corporation does. That's complete control. What if they have costly hardware requirements? So years ago, you could mine Bitcoin, for example, or you could even act as a validator on Solana, but using your laptop, you cannot do this anymore. So the problem is, and I mentioned Solana here, when it's extremely expensive to validate, that means only large corporations can afford to act as a validator. Of course, you can delegate, but that creates another problem. Let's see, next point. Some forms of modular blockchains, such as sharding. So when you shard, you basically creating or divvying up the validation process. Or there's other ways of having a modular blockchain. Like some people say Polygon is a modular blockchain because they don't do the consensus, right? Ethereum does a consensus, the security for Polygon. But the point here is when you have complicated sharding, you have its own issues. And for example, one of those, I'm trying to think of how to say, one of those shards, I should say. What if there's 10 shards and one shard only has 5 validators? That increases control on that particular shard. And the same thing when you have subnets like an avalanche, the same thing can happen. So let's go to the next one because there's a lot to talk about. Censorship. When there's censorship, for example, Ethereum is very decentralized, but over 60% of its blocks are OFAC compliant. So if you can censor on Ethereum, is it really decentralized? Next point, governance. If we mentioned this earlier, if governance is centralized and off-chain, so how much control, or less, how much decentralized control is there, right? Because it's not on-chain yet. So you want on-chain governance. So again, on-chain governance is a form of decentralization. And second to last, software. If there's faulty code, then that blockchain can be hacked and controlled. And lastly, people don't think about this, but in a proof of stake, especially proof of stake blockchain, in order to control the network, you need to gather up as much of those coins, those tokens as possible, right? And there's a cost to it, right? If you're paying a penny for a blockchain that's a market cap of $10 million or $1 million, It's nothing to take control, to get over 50% of those validators, right? It's nothing, right? You only need to put up, for $1 million market cap blockchain, you only need to put up $500,000. So then you can control it. So I'm saying here that market cap matters, because if you have a large market cap, we're talking Cardano here, and they have, not only do they have a large market cap, but they have a lot of validators. So it's going to be very difficult to take control of Cardano because its market cap is so high. So think about that. That's like another aspect of control. So sources of information. So how do you get information on decentralization? Of course, you can go to the source. Look at white papers, blogs, blockchain blogs, explorers. You can look at secondary research, which has become more and more important. And you can see one I've highlighted here from Missouri. You can look at token insights. You can look at data websites such as Dune Analytics and Nansen. You can look at Glassnode, for example, and CryptoQuant. So here's a table from Invest Answers that does great information when it comes to terms of quant. They really rely on quantitative analysis. I think maybe they rely too much on quantitative analysis, but it's very important, especially since there aren't too many people doing that. So what they did here, they made a table that looks at active validators. It looks at the Nakamoto Coeficient. And one thing I think is really interesting, they show the date of the launch, because that's important. Obviously, if it's a new blockchain, it's going to have fewer validators compared to a blockchain that's been around forever. So let's look at the third column. You could see that Bitcoin and Ethereum has a lot of nodes, and so does Tron. Even Elrond and Cardano and Solana and Algorand and Avalanche, they have a lot of nodes. And just be careful. There's active validators and then validators that are seen as like supervisory validators or nominated validators, and those are important too. So if you look here at Polkadot, it says that they have only 298 validators, but it's more nuanced than that. It's more complicated. They have other validators that do other things that make that particular blockchain decentralized. So then if you look at the next column, column 4, you can see the Nakamoto Coeficient. So I'm going to have a sip here, and you could take a look at that and absorb it. So if you took a look at that, you can see that maybe you can notice two things. Number one, Nakamoto Coeficient overall tends to be pretty low. Number two, there's some well-known chains. You can even get the Nakamoto Coeficient. 3, what he didn't talk about here, which is very important, is I think you need to see the number, the Nakamoto Coeficient compared to its active validators. So I think overall you want to see a number around 10 or greater. But it really depends on each particular blockchain. So some good ones are Ethereum, Cardano, which I mentioned earlier, Solana, Algorand, I don't know, maybe, but I mentioned to you earlier why it's not good. Avalanche, maybe. There is control by Ava Labs. Polkadot, a definite yes. And Cosmos, maybe. Polygon, which is a big, well-known chain, no, it's very centralized. And you can see that here, and it's Nakamoto Coefficient of 3. But what I like to do is take that number and divide it by its active validators. So if you took Polygon's number of 3 and divided by 109, you get about 2.8%. Meaning, and this is a simple definition, meaning you could, that if you acquire or take control of about 2.8% of the validators on Polygon, then you can control Polygon. And in this case, I think it's actually true because of what I mentioned earlier, that the founders of Polygon do have control of that chain. They had the whales that control the tokens. They own them. They control the administrative keys. So they do have control. So that's a clear example where the Nakamoto Coeficient shows that Polygon is not decentralized. Now, a good example where where I was going to say Polkadot, where the blockchain is decentralized, is Polkadot. You could see you need a higher number of nodes, or I should say there's a higher Nakamoto coefficient of 16, but it's not very high, because this only tells you half of the story, as I mentioned earlier. But you can see at least that number of 16 is higher than Polygon's 3. Another one is Solana. That's a good number, 31 versus 2,074 validators. So this is a very good one. And as mentioned earlier, you also need to look at how old the chain is. So let me find an example of a chain that's young, like Solana. Solana is only a little over 2 years old, but it already has over 2,000 validators. So it's moving in the right direction. And you can see in the last column they have validators added per day. That's a very good approach to it. So now I'm going to give you specific examples of what to look at. So I'm only looking at, this is Ethereum. So yes, I'm only looking at Ethereum, but I'm only looking at staking. So here you have Lido or Lido. You say potato, I say potato. So Lido Finance has 31% of the stake Ethereum. So that's a no-no. So that is one source of centralization, not decentralization, centralization of Ethereum. And another source I mentioned earlier was that there could be some censoring on Ethereum. I mentioned that earlier with OFAC. The next chain I want to look at is a chain that's not fully decentralized, but they're doing such a great effort at moving towards decentralization. I want to highlight them. And this is Solana. On the top left, you can see that they have a chart, a historical chart of the number of nodes on their mainnet. And you can see it's been going up over time. And then on the lower left side, they have the Nakamoto Coeficient. Again, you can see it's going up over time. That's what we want to see, that they're making an effort to become more decentralized. And at the top right, you can see the distribution of what's staked by country. And in the lower right, and this is getting a little technical, you could see Solana's stake distribution by ASN, autonomous, I forgot, I just got a brain fog, but autonomous, what is it, automated, I just forgot what it means. But basically, you want to make sure that that's getting more decentralized over time. And the last example I want to give you is the project that I think is one of the most decentralized, and that won't be labeled as security for a few reasons. Number one, it's inflationary, and that makes it more decentralized in a way. I mean, that makes it less of a security because the debasing Polkadot over time. So I want to also talk to you about their legal team. Polkadot actually met with the SEC, and it was concluded that they are not a security, that the software, you could go on, this is the right photo I've got here from Twitter was from January 26th, and the Polkadot and the legal team has said that they're not a security. In order for them to say that, to be so secure to say that, they had to prove to the SEC that this decentralized. And one way is by showing how these validators are chosen. And you could go onto their blog and they talk about that, how they have nominating validators and active nominators, validators. It's not concrete. It's not that simple. They try to do a good job at keeping the validator process fair, and you can look at that on your own. But on the top left chart, I did want to show you the Nakamoto Coefficient from Polkadot Insider is number 1 at 82. Just be careful. You might say, wait a minute, you said it was a lower number on the other slide. Yeah, the Nakamoto Coefficient changes by the day. So here you can see that the Nakamoto Coefficient is 82, which is higher than Avalanche and even Solana. So but we got to talk about decentralization. So in terms of the coefficient, yes, they're number 1. But like I said, in terms of decentralization, you also want to look at it holistically. So I would say holistically looking at the most decentralized chains are Bitcoin, which is not here, Polkadot, Solana, Near is, we didn't talk too much about Near, but they have a specific program to rapidly increase the number of nodes and decentralization on the blockchain. So I would say looking forward, Near is definitely one of them. BNB, I'm not sure. I would say no. And Cosmos and Polygon and Phantom, no. So it's still a few chains. Even looking forward, I still think it's just a few chains that are truly decentralized. So one last thing, before we go, which I did not discuss, community. Sam Bankman-Fried, he might be a fraudster like Madoff, but he did say one very important thing. He did say that community is vitally important to Blockchain Project. And that could be a few things. But one way of looking at it is it's just simply looking at the Twitter. How many followers do they have on Twitter? How many people follow them on CoinMarketCap? It's very, very important. How many people follow them on Reddit and Discord and Telegram? So this is very, very important. Why? Because if a project has a big, active community, they're going to be more vigilant and they're going to be able to spot any suspicious activity on that blockchain project and prevent attacks. And I leave you here with a quote from Steve Jobs. He said, "Sometimes life is going to hit you in the head with a brick. Don't lose faith." And the reason I said this one is I'm alluding to Solana. Solana had a near-death experience, as we all know, with FTX and Alameda, but they're coming back. They're not giving up, and neither should you. So that's all, everyone. I hope you enjoyed this blockchain decentralization presentation. And I just want to remind you, I am not paid for anyone to do these reviews. And this is not financial advice. I'm just here to educate you. And please don't forget to like us and subscribe to us and tell your friends. Bye-bye.